Welcome back, mathematicians. In this video, we are going to discuss polar equations. So a polar equation is an equation whose variable are polar coordinates. And so those polar coordinates are r and theta, r representing a radius, a distance from the pole, and theta being the angle from the initial side, which would be the polar axis, which corresponds to the positive x-axis in the rectangular coordinate plane. The graph of a polar equation consists of all points whose polar coordinates satisfy the equation. So here I'm giving you, to start on the left, an equation r is equal to 2. This is an equation in polar coordinates where you have the radius equal to 2. Notice we do not have the variable theta as part of this equation, which means that theta can be anything. So every angle that exists will result in a radius or distance from the pole of 2 units, which means that we get a circle when graphing this equation. That same equation, or rather that same graph, when put on the rectangular coordinate plane, would have a circle with the center at the origin and a radius also of 2 units. The equation for that circle would be x squared plus y squared is equal to 4. The goal for us in this video is to convert equations in terms of r and theta that are polar equations into their corresponding or counterparts in the rectangular coordinate plane, meaning that they will be in terms of x and y. They do result in the exact same graph, meaning the shape of the graph and the characteristics of the graph are the same. It's just that they're graphed in the xy rectangular coordinate plane rather than the polar coordinate plane. So that's our goal for today. And in order to do that, what we'll need to do is know a couple formulas. So the first formula that we'll need is x squared plus y squared is equal to r squared. The next formula we'll use is the fact that tangent of angle theta is equal to the ratio of y over x. Another formula we'll need is sine of angle theta is equal to y over r, which we will then take that formula, multiply both sides by r, to get a more user-friendly formula of y equals r times sine of angle theta. And then likewise, we have cosine of angle theta is equal to x over r. One more time, multiplying both sides of this equation by r will result in a better version of that formula, which is x is equal to r times cosine of angle theta. Here we have an equation where we are being asked to convert this equation in polar form to a corresponding equation in rectangular form. We just saw what this looks like when graphed. We know it's a circle and we know the radius is equal to 5, but I did want to walk you through the algebraic manipulation in order to convert to the corresponding rectangular form of this equation. So to do this, we will actually start by squaring both sides of the equation. This results in a new form of that equation of r squared is equal to 25. We then can replace r squared with x squared plus y squared because, as noted just a minute ago, r squared is equal to x squared plus y squared. So we'll use substitution to replace the r squared with x squared plus y squared. This gives us an equation in terms of x and y, in terms of rectangular coordinates, of x squared plus y squared is equal to 25. That results in the graph of a circle with the center at the origin of 0, 0 and a radius of 5 units. So to graph this in the polar coordinate plane, we would go ahead and plot the pole as the center. We would then go 5 units away from the pole to get that concentric circle that's 5 units away from the pole. So 1, 2, 3, 4, 5. So it happens to be this circle here. Draw the circle to the best of your ability. And that is the graph of the equation in polar form and also rectangular form. So again, if I were to plot the same exact circle in the rectangular coordinates in the rectangular coordinate plane, what I would notice is that it's the exact same circle with the exact same characteristics. The center would be on the origin and the radius would be 5 units. Here I'm giving you a polar equation that is theta is equal to 3 pi over 4. Notice the absence of the variable r in this equation. So what we'll do here to convert it over to rectangular coordinates, meaning we want to replace any theta and or r with x and or y. To do that, we're going to take the tangent of both sides. So tangent of angle theta is equal to tangent of 3 pi over 4. Now the reason we are doing this is because tangent of angle theta is equal to y over x, meaning it is the only trigonometric function that is in terms of y and x and not r. So what we'll do is then replace tangent of angle theta with that ratio of y over x, and then we will evaluate the right side, tangent of 3 pi over 4, which we know is equal to -1. Now this has been converted over to rectangular coordinates, but what I'd like to do is actually change the form so it's a more user-friendly format. So I'm going to multiply both sides by x, resulting in a new form, which is y is equal to -x. I can see here this results in a linear equation, which means when graphed it results in a line. The slope of the line happens to be -1, and the y-intercept is going to be the origin 0, 0. To graph this on the polar coordinate plane, I'm going to start by marking the pole. Then I'm going to mark a ray extending towards 3 pi over 4. But this can't be it because of the fact that in this case, r is not being defined, meaning r can be anything. This ray represents positive values for r, but if r can be anything, it also can be negative values, which is why we also extend the ray towards 7 pi over 4. And so as a result, we have a line, which by the way, if we graph this exact same line, meaning the equation y equals -x on the rectangular coordinate plane, we should get the exact same line. We should in fact be able to take both lines on both coordinate planes, put them on top of each other, and they should be the exact same. All right, guys, good luck.